Yeah, if you don't want to review the dice stats lab, that's fine. We can just not review that one. Everyone, give me a yes on the board if you want to go over the both labs, or no if you want to go over just the tic-tac-toe and not the dice stats. Okay, everyone vote. Everyone vote on the participants board. Oh, the yeses are taking it. All right, it's 11 to 8 right now. There's more than 19 people in this class. There's 34 people in the participants list. I need all 34 to vote. Do you want to go over both labs? Hit yes. If you want to go over just the tic-tac-toe, hit no. I don't want to hear it in chat. I want to see it in the participants window. So yeah, use those like reaction thing. It'll lead no once the mail-in ballots come in. Oh boy. Yeah, Pennsylvania switched blue. That was a fun one to see. I don't know if anyone saw his last speech, but it looked like he was going to cry on stage. It was kind of funny. You know, it'd be the best though if Joe Biden, if Joe Biden tweets out to him, or like on the day of the like if he you know, if nothing else goes screwy on the day that he's out, just be like, Mr. President, you're fired. Can you imagine Trump would like fly at him, just dive at him? It looked like Trump was gonna cry on stage. He was talking about how it's a scam, and it literally just sounded like he was about to cry. His voice kept breaking. Oh, dude, whoever wins just needs to be like, Mr. President, you're fired. And I want to see that reaction. Okay. The yeses do have it. It's 15-10 right now. Majority of the class has voted. We are going to go over both labs. I'll go over the dice labs quickly because that one should have been easier. Right now, people coming in late. All right, so we'll go over both. Dice stats. This one should have been mostly straightforward. Oh, I should put on a. Yes, I need to put up a chat so I can see what people type. Excuse me. Got classes that start at 12. Yeah, that's fine. Set it, yeah. Set like a calendar or something for yourself if that helps. Alrighty. So here's the dice stats lab. Yeah, the equations might have been the one part that was kind of hard, and I'll kind of go over how I did that. If you guys remember, so I guess we'll go into that first. So I just threw in my data as an array, and then I'd already calculated the mean. You know, and the mean is calculated here. The mean one I think should have been the easiest for you guys to calculate because it's just an average. Everyone knows how to calculate an average. So for the standard deviation, we needed to know what the mean was. And then I had a for loop. I'll put this on a new line just so it's easier to read. In the for loop, I had a running integer. I had a running double called sum. And to this, I just added and if we look at what, how to do, look at the equation here. If we look at the equation that we had over here, Standard deviation is just the sum of each element subtracted by the mean squared. This equality is done for each individual element. And then we divide it by the total number of elements in the list minus 1. And I'll just update that over here real quick. Minus 1. The minus 1, for those of you who are curious where this comes from, this is just the statistics equation. When you get to statistics, there's two different kinds of stats to consider. There's a sample stats and the population stats. Population is a more theoretical number. It's an extrapolated number. So, basically the way you extrapolate a sample is, or a population is, I have a large quantity of large samples around this one demographic. And because I have so many large samples, I can use this to make a claim about the greater populace. So let's say I wanted to know if all the people in the world, if they like chocolate, yes or no. That was the question I was asked to them. And I collected like 10,000 people from one state, 10,000 people from another. And, I went through and I calculated 10,000, I got a sample of 10,000 people from each state. That, I could combine that sample data. So there's 50 times 10,000, so 500,000 data points. I could combine that and you say, okay, with these 500,000 data points, I'm gonna make a claim about how much people in America, what the percentage of people in America like chocolate. All of America, all the populace of America, not just these individual states. But anyways, when you're calculating the standard deviation for the population, it's over n, and when you're doing it for the sample, it's n minus 1. I can't tell you the theory and the math behind it, but that's how it works. Can you post the code later? I don't post code, Brandon. The reason why is I've had issues in the past where my code ends up on like Stack Overflow or Chegg or wherever else, like students share it. And, this is one area where I can control if students share it or not. If I don't post it, people don't share it because I reuse this stuff. So if my code is posted online, then people just copy my code. And I see my implementation show up on people's homework, and I don't like dealing with that. So I'd rather, if you're gonna copy my code, I would rather you at least watch through the video, so at least you learn the principles behind the code and you're not just copying code. Does that make sense? Because I think a lot of times with these sorts of things, people just copy paste the code. I'd rather have some control over it. It's gonna happen regardless. I know I'm not stupid, but I'd at least rather make it a little bit harder for you guys to, for people to cheat. So anyway, let's get back to it. So here's the equation we want, and here's how we would do it in code. For each element, we take that ith element, and then we subtract it from the mean, and then we square that. So this data I minus mean is the inside of the parentheses right here, and then we square it. And that's the numerator. And then we just square root that sum that we just calculated. Oh wait, this is not gonna work. This won't work. Oh yes, it will. No, because yeah, the loop goes through, it calculates this whole sum. So we've done this xi minus mean squared. It just comes with experience, Matthew, honestly. I strongly encourage you guys when you write your code to go back and be like, okay, where can I cut lines? What is extra? What don't I need? Because I take a lot of shortcuts of I'll put things on single lines, or I'll use printf to reduce the number of lines I have to write for output. It really just comes with experience and seeing other people's code. Maybe I will post the code. I don't know. We'll see. We will see. I might post the code. I have to think about it. But it comes with experience and time. Don't be discouraged that just because, your code is so much longer than mine. It took me a long time to get to this place. It's just a lot of practice. You keep practicing at it, you'll write code that's really short too. But it's a double-edged sword, because sometimes in an effort to always make your code more efficient, you end up over-engineering your stuff, and then it becomes needlessly complicated. So it's always the give and take. Anyways, back to this. So for each xi, we go through and we do the sum, and then once we have this summation for the entire list of data, we just divide that by the number of elements minus 1, because that's the equation, and then we square root it. Oh, over here, sorry, excuse me. So it should be this. I did that wrong. Should be that. There we go. And then we just square root it. And that's how you calculate standard deviation. And it's okay if you had extra variables in here to hold stuff. That is totally okay. I encourage you guys to go back through and review and be like, okay, which one of these variables might be extra? What are extra lines that I don't need here? And think about how to make your implementation shorter. It's a really good exercise in my opinion. As for my data, I just had one array of dices, which actually it wasn't even necessary. So I can actually remove this. I don't even need that because I never use it. And I just did, over here, D4, roll 4, roll 6, roll 8, etc. So on and so forth. And I just hard coded the stuff, and that's how I populated my sample. And then after that, after I calculated each one, I just reported the results. If we go to report results, we calculate the mean, standard deviation. We also calculate the practical mean and expected, which is just the mean and expected rounded down. And yeah, and then we print out the results. And we do that for each dice. I think maybe something that might have made a lot of you guys' things longer, you maybe had like repeated code somewhere, or maybe you had this stuff arranged differently. Like maybe you report the results at the very end and you populate these together and you initialize them together. It's really up to you. It doesn't matter. But yeah, that's a dice set. It's a very easy lab. I think it was just really poorly written by me, and that caused a lot of confusion. But it's, yeah, this was it. So for the tic-tac-toe, there was a question of how do we change players? So I always say this, there's a lot of ways to skin a cat. There's a lot of ways that you can alternate the change of players. You could have a Boolean here called Boolean is P1 turn. So it's player one's turn, and they'll say it's true. So we start out with is player one's turn. And then over here, we have something like, we'll initialize that over here, and we'll say is P1 turn curve player equals P1, otherwise curve player equals P2. And I don't know if Java actually facilitates this. Yeah, we'll just say P1. We'll say it's initially P1. I guess not. There's some languages that allow you to do your if statements like that, and we'll say if is P1. If it's not P1's turn, then we'll say curve player is equal to P2. Because if it's not player one's turn, then it's the other player's turn. And and then at the end of it here, we'd have like, if is P1 turn, then is P1 turn equals false. If this was true, we set it to false. Otherwise, we set it to true. Oh yeah, Diego, you're right. That is how you do it. Sorry. That is how you do the, I always forget what that notation is called. But yeah, you could just do char current player is equal to this, if you really wanted to get very efficient with it. If its turn is even, then it's P2, otherwise it's P1. It should be turn divided by 2. Turn modulo 2 is 0. That means that's how you know it's even. turn modulo 2 remain equals 1 will give you, I don't know if that works all the time. If it's odd, oh, it will work actually. If it's odd, it will always be 1. No, Diego's right. Okay, so yeah, this is how we could do it. It really just depends. You know, this equals 0 checks for even, this checks for odd. Whatever you want to do, it's up to you really. But this is how you alternate the turn, and make sure you increment turn at the end. And I use this approach here because I also use turn to check if we have a cats game, meaning because this is a 3x3 board, if we've had 9 turns and this thing hasn't happened yet, then it means that we don't have a winner. That's one way you can kind of manipulate logic in your code. Because if we come here, we check this first, right? We check to see if there's a win on the board. If there's a win, then we announce the winner, and then we break out of the loop. We end this entire loop thing right here. It's the same as a return statement. So we break out of the loop, and we don't execute the rest of this code. But if we don't come here, and we come here, and it is the 9th turn, and there's no winner, because if there was a winner, this would have executed and we would have broken out. If there's no winner, then we say, hey, it's a cats game. It's a tie. There's no winner. There's other ways to check if the board is full too. Whenever someone puts a mark, you could also count your, let's say you had count X and count Y, right? You were counting how many X's and Y's there were. There's a pseudocode over here. You could say if count X plus count Y is equal to is equal to 9, then that's how you know you'd have a tie game if the number of marks, oh, sorry, not Y, O, like if you counted X's and O's. So the number of X's placed and the number of O's placed was equal to 9, then you'd have that. My game also doesn't check to see if when placing, like when the user puts their mark on the board, I don't check to see if it's already occupied. I should actually have a separate method that breaks off from here to check to see if the square that they're trying to put in is taken, but that's more error handling, and I don't really want to deal with that personally. As far as checking the win condition, I just did it the dummy way, right? I gave, at the end of each turn, we check for the winner, right? Because when we come in here for this if condition, this method has to run. So we pass the board state. We also tell them who the current player is after they've made their move. And then we check the board. Do they have a win on row 0? Do they have a win on row 1? Do they have a win on row 2? You know, do they have a win on column 1? Or do they have a win at a diagonal? Do they have a winner at the opposite diagonal? Do they have a winner on columns? I do all these checks manually. And then if none of these are it, then there's no winner, and we return false. So that means we don't execute here. This is the really lazy dummy way. There is a more elegant approach to this. I couldn't be asked to find it. So yeah. There's definitely a better way to look for this, but I just didn't want to look for it. You made a list? Oh, you made a list of win conditions. Yeah. I guess that's another one you can do too. Sarah, this wouldn't work for the any size. I don't have the implementation for the any size because I just haven't had time to work on it. In the coming weeks, I'll work on it and put it up.
Could I share like my approach for the any size like win conditions?
Yeah, go for it.
I had like a implementation that worked like this. So basically, I would check I'd say that there's 4 different ways to win. Either you have a vertical line, a horizontal, a diagonal going from top left to bottom right, or a diagonal going from top right to bottom left. The reason why I broke that up into 2 different conditions is because of like it's just like my approach. It makes sense in my head because when I'm like basically iterating the 2D array, I want to move like +1, +1, +1, +1. That's top left to bottom right, if that makes sense. So those are the four like ways to win. And so I used nested for loops for the vertical and horizontal lines. And basically how it works is I would initialize like a counter. I would call it like number of X or number of O, because they're different like marks. And then I would see if after going in a straight line down or a straight line across or diagonals, I would see if there were 4 in a row or 3 in a row or 5 in a row of the same thing. But as soon as it's something different and it detects that, I'll reset the counter. So there's no way it can guarantee it.
You could also just return, like break the loop at that point too.
Yeah.
If you encounter something, you don't need to read the rest. As soon as you encounter something that's not the same as the previous element, you can break.
And that's pretty much my approach. That's how I decided to implement it.
Yeah. Yeah. So basically, let's go to the whiteboard here. So the basic approach, and again, this might be even like the least elegant of the more elegant approaches. Suppose we have some number of rows and columns, right? This goes on for infinity here. This goes on for infinity here. And the diagonal also goes on for infinity, right? We have to n. We have an n-sized board. The way we check for the win condition is first, I would say, have one nested for loop that goes row by row by row. And on each row, it checks each column. So you'd have a nested for loop like, you'd have a nested for loop like for, we'll call it for r is less than n, and I'm just using, pseudocode here. And then the rows are remaining consistent each. So for column is less than n, column plus plus. If array at r c is equal to array at r c minus 1, then we keep going. Which may be a better way to check it. Is to break. And or we could actually, better one be to have a Boolean flag of something. Flag is equal to true. Set it to false. And then when we, flag equals false, I should say. Flag equals false. And then if we get to the end here, if flag is true, then congrats, I guess. Like this would be kind of the rough code for just the row. And then you'd inverse it for the column. You'd go for each column, and then you'd have the columns on the outer loop and the rows on the inner loop, right? So that for each given column, we check each row. And then for the diagonals, there'd be some more math involved. I don't really feel like getting into that one here because I just wanted to look this one very quickly, and also wanted to talk about this thing. So there were a lot of questions about how I made it so that in the 3x3 array, we'll just start with the 3x3 example and we'll do a few other cases. So I numbered this, I labeled these 1 through 9, right? 4, 5, 6, 7, 8, 9. And if we look at the indices for the rows in the column, right? This is how we refer to it from a 2D array perspective, right? We'd say 0, 0 is 1, or 0, 1 is 2, etc. The way I convert these is basically by doing some integer math. So first things first, I want to, instead of numbering these, because these numbers are labels, I just want to do it an easier way first and just use the indexes, right? So I have 0, 1, 2, right? Because we start counting from 0 when we're indexing things. 6, 7, 8. There are 9 elements, but it's numbered 0 to 8. Then I do this. Oops, 0, 1, 2, 0, 1, 2. Already we should be seeing some relations between these numbers. So we have the number 6, and actually what I'm going to do over here, I'm going to color the rows and columns differently. So if we look at 6, these are the two numbers involved in 6. So just looking at these numbers, using just 6, integer 6, what can we do to get integers 2 and 0? What do you guys think? Because we know we need to perform some kind of operations. Yeah. So 6 divided by 3 will get us this one on the right. So we'll say divide by 3. Yeah, and on the right, we do modulo 3. So Johans, tell us, where did you get the, where did you come up with the 3? Where do you think this 3 comes from? Exactly. This system works for when it's a square grid. So 3 is n. So if we write kind of a general formula for this, you can say, and I'll do it with text. Yeah, exactly. So I, which is the index, divided by n is equal to the row, and I divided by, or modulo n is equal to the column. I'll spread this out a little bit so it's easier to read. Okay, cool. And where I is the index. So now let's look at, let's go back to the labels over here. So if we look at this, so first let's test if this theory even works, right? So we have 6 here, so 7. 7 divided by 3 gives us what, guys? In integer math, what is 7 divided by 3? Oops.
2.
Yeah, exactly. And then what is 7 modulo 3? 2. 1, yeah. And does that work? Our row is 2, our column is 1. Yeah, that works. By the principle of mathematical induction, we can say just because we tried the nth case and the n plus 1th case, we can say that this checks out. So let's test it for here. So in this case, well, we have 7, but we know that this would have given us 2, 1. Why isn't it working here? What do I need to do to change this label? What is wrong with this number here? Why does it work for this list, but not for the other one? Everything is off by 1, right? Because 1 modulo 3, 1 divided by 3, 1 modulo 3 would give me 0, 1, not 0, 0 like we expected to here. What's the difference? What's different between these two lists? Exactly. This one is a label. Our label is off, in this case, it's off by 1. So our index is equal to, if we think of it, a label minus the index, right? We, our index of 0, I should say. Have a label of 0 is by the x of 0, whatever like the difference is. So in this scenario, we'd have to say 7 divided 7 minus 1. So 7 minus 1. What is 7 minus 1 divided by 3? And we'll put that in parentheses. What's 7 minus 1 divided by 3? 2. And what's 7 minus 1 modulo 3? 0, exactly. And does that give us what we expect? 2, 0. Yep. Does this make sense? Does this system that I did here make sense? And we can do this for an array of any size too, so long as it's square. So long as the array is square, write this here. So long as the 2D array is square, r equals column, then r is equal to I divided by n, then column is equal to I modulo n. This is the formula we can use to generally make any kind of square 2D array number it from 1 to n, or 0 to n, or whatever we want, right? Does that make sense for everybody? And remember that n is n equals dimension of, is the square dimension. So if it's a 3 by 3 array, n is 3. If it's a 6 by 6 array, n is 6, etc. Does this make sense? Anybody still have any questions about this? No? Okay, cool. In that case, let's go back to here, and we'll go over what we guys have to do for this coming week. So today, before class, you should have already completed this quiz. I will grade that over the weekend. Coming up next week is the milestone 2. So what we're going to do, actually, before I go into that, let me really quickly go over the pre-lab for next week. This is hidden from you guys. Did I actually finish this quiz? Or did I just, no, you're not going to have a quiz, don't worry. Delete. And I'll show section. I guess you guys should be able to see this now. Settings, I just want to make sure this one is, okay, cool. Cool. That's next week. You guys are going to read these sections on classes and objects in Java. And then you'll want to practice the code samples in your own IDE, just play around with them. You can just copy paste this shit into your IDE and run it. And just play around with it and get a feel for how objects work in Java, objects and classes work in Java. Then what you want to do after you've sampled these, you don't have to copy paste the code to me, but you need to send a PDF that talks about what you understand how you understand classes and objects to be, like what they are. Describe how you can use objects and classes in one of your previous labs to make it easier. This could be your labs in 211. If you want to talk about maybe an assignment you did for 210, you can do that. But if you do that, you need to explain what the assignment was, like what the big picture thing you have to do was, what implementation you took, and how you would revise it to accomplish that. Yeah, there should just be like a text submission box. You should be able to just write it directly in there and I can read it. But yeah, just talk about how using classes and objects makes your code more efficient, how you could use it to revise your other code. That's all you really need to do. It's a reflection.
Just real quick,
Yeah.
Did you say to write it in the box or to submit a PDF?
Apparently you write into the box. So if I go to this.
Oh, okay, so I don't need to make it into a PDF.
Yeah, it says write it. I mean, if there's no submission box, then yeah, you obviously make it a PDF, but otherwise just write it to the text box.
All right, cool.
So for milestone 2, What we're going to do for milestone 2 is write the dungeon exploration. So you guys, for milestone 0, had to design some kind of dungeon. You had to design a map for it. And now we're going to start using that map to allow the player to explore it. One of the things I recommended for milestone 0 that you guys do was to use a website called Don John. I'll put this up in the Discord after, actually you can put it up now. 211, and I'll put it over here. Okay. So you guys have to build a map. And the reason I like this thing, you don't have, it just creates a map for you, and you don't have to use the whole thing. You could just like take a segment of it if you wanted. But the reason I like it as a demo is because if you click on these areas, it tells you like features of the room. What does it look like? How can we describe this room? What things are in this room? There's stuff like traps and whatnot. You don't have to worry about that for your exploration. I just want to be able to explore the dungeon, and I'll show you how to be able to do that here in just a second. But do you guys remember when we built the Mad Libs demo the other week, where I showed you how to use command line arguments, and we built like a Mad Libs thing? Do you guys remember that? That demo? I was showing you guys how to use command line arguments, and we just made like we would like build the Mad Libs dynamically based on however many arguments we gave it. So, you know, if I said something like edit configurations, and this is also how you do stuff from the how you can test command line arguments inside of IntelliJ. So, you know, if I said like, if I just gave like a bunch of names, Turk, Taco, Plain, Dog, Grass, 22, let's add some more, Blah, Foo, Bar, 130, 123. We say, okay, and we run this thing. We get a bunch of Mad Libs based on this little random assortment. So we would take all the words that we gave in the args list, and then we, you know, dynamically create Mad Libs over here, right? So here's Turk, Taco, Plain, Dog, Grass, 22, 123, Bar, Foo, etc., right? You want to kind of have something like this when describing your, not exactly because this is random, right? But when describing your dungeon, you have like a room number, right? And based on what the room number is, maybe you have like a switch statement of the room descriptions of the various room numbers. So that could be something you should go in. It'll make more sense as I explain more of the dungeon. I'll give you the example. So let's say this was my dungeon map. I took my dungeon map and I just drew grids over it, like larger grids. This is going to be my 2D array. If you really, really want to go all out, you can make each one of these squares be a array square, right? And you could like do a one-to-one of your map into the game. You don't have to do that. And in fact, for your sanity, I recommend you don't, because it's going to be really annoying to do that. So it might be just easier to break it up into general sections and be like, okay, this square represents a part of room 2. This is a hallway, because that's an H. This is room 5. There's more hallways here. And yeah, so real quick, if this is a 2D array, what data type would this 2D array be, since we have both numbers and letters?
String.
Could be string, but char I think is easier to work with, because that way we know for a fact it's only ever going to be 1.
Right.
And then when you go to like print it out, it'll look much more neater, right? So what I want from you guys is to have, you're going to have a zip file that's going to contain your code and your documentation. In the documentation, I want to see your original map, and I want to see something like this, how you adapted the original map to be inside of a 2D array. The rules are, you cannot move from a room of 1 number to a room of a different number. Imagine there was a wall between these 2 rooms, between 5 and 7. You can only go from a room to a hall, and from a hall to a room. You can also go from like room number to the entrance or exit. But yeah, you're gonna have an entrance. You're gonna have an entrance point that the player starts in, and the player is gonna move through the dungeon and explore. And like here, I give kind of a rough overview of how it would work. So we start at the entrance, and my game says, "Hey, you're in the entrance. Your environment looks like this. To your south, to the south of you is the room. To your west, or excuse me, to your east is a hallway, and then there's walls to your north and west. Right? You can't go north or west. So you ask the user, which direction do you want to go in? And it should dynamically tell them, based on where they are, which directions they can go, north, south, east, west. These are the only directions that you can go in. If your map is linear, that's okay. You can always just try to like bend and curve it around. I would prefer it to be something explorative like this in 2 dimensions. No diagonal movement, only vertical and lateral, or vertical and horizontal, I should say. And in each of these squares, it's going to prompt the user where they can go. Like for instance, here, like I said, you can go south or east. Here, I can go north or east. Here, I can go any of the 4 directions. From here, I can go north, west, or south. I can't go east because I'll be crossing over. It's a different room and there's walls between different rooms, right? It's okay to have your rooms take up, have a single room take up multiple squares like this. That is totally fine. But, and you can move within that room, but you can't move from one room to a different room. And the objective is for the player to get to the exit. So in my map, he could go here, then here, then here, down into this room, and then come out the exit here. He could also go around this way through the hallway to get into the exit. Either one of these works. Something to note, something that I talked about in the last class, I want to talk about with you guys. When I declare, so first of all, what's the difference between a declaration and initialization? What happens in a declaration? What does a declaration look like? Everyone in chat, declare a variable. Any variable, doesn't matter what type it is, what its name is. Yeah, int x. This is a declaration. When I do this, what is the value of x? Brandon and Alan are correct. No value, it's null. X is equal to null right now. And then when I initialize, some value to it, that's when it has a value. Newer versions of Java are smart enough to try and initialize declared variables to the 0 value. Don't count on it. It's better to assume that it's going to be initialized to null. Because more often than not, it will be initialized to null. It only does this in the back end when, like, let's say you declare an empty integer, but then you say integer plus plus. Your compiler might be smart enough to, at that time in runtime, be like, oh, okay, x doesn't have a value yet. Let's quickly initialize it to 0, and then we'll increment 0. But again, that's something that you can't rely on, that you shouldn't rely on, I should say, because you don't know if one interpreter might read it that way or not. There's a lot of factors in the error, and it's better to assume that the standard is what it's always been in other languages, is that it's initialized to null if you don't declare a value. So that is important to note, because these empty squares, which you can have in your dungeon, should be null. So your dungeon should also be able to handle a case where an adjacent square might be null, right? And if it's null, you just, make sure you don't describe anything in there, but you just tell them, like, you don't offer this as a direction they can move in. And you have to make sure that while you're allowing them to move, they stay within the array. You might, while you're testing your game, you might run into a lot of index out of bounds error exceptions. That's what that means. If you get an index out of bounds error, it means you queried your array at an index that doesn't exist. So let's say your array was 3 by 3. If I try to go array 3 or 2, 4, let's say, this is way out of the second dimension is way out of bounds for my array. I don't have in my 3x3 size array, the max index on either end is 2, right? I don't have an index 4 on either side. So I'm going to get an error here called index out of bounds exception or something like that. I'm going to get that error from Java. That's what that error means, is you actually try to search somewhere. If you get this error and you're not sure why you're getting it, use the debugger, see what value it's generating, and trying to query at. That way you'll know. So one important thing to leave you off with, you are the dungeon master in this game. This is your game, this is your dungeon, and you're the dungeon master. So if you've ever played a game like Dungeons and Dragons, you need to, it's important for you to describe the setting really well so your players understand what's happening. Because they don't always have a map in front of them. They don't always have visuals. So it's up to you as a dungeon master to be able to describe the game so that the user understands. And this is where this user experience points are going to come in super handy. In fact, I'm actually going to change this. I'll say this is 5 and this is 15 because I think it's super, super important that you guys nail the user experience in this particular assignment. It's not that hard. It is not all that hard to, parse through a 2D array, to loop through it. It's going to really separate it's going to be important that for this, you nail down the text-based descriptions because that was one area that I noticed was lacking for the last milestone. You guys, some of your games didn't feel like a game or it didn't feel like great to play because I didn't understand what was happening. So being able to clearly describe what is happening in your program is a very, very important skill to have. So I really want you guys to consider the user experience when building this milestone. And as I said, for your final submission, you're going to have a .zip that is going to contain your dungeon exploration.java, and it's going to have a documentation that contains something like this, what your initial route map looks like, and then how you kind of divide it up into a 2D array. If you want to talk about like each room, if there's specific unique features in your game, you can talk about that in there, or in your exploration, you can talk about that here. But really all I want for this one is just kind of be able to like take a tour of your dungeon, right? You're just adding in movement into your game right now. That's all you really need to consider for this milestone. Any questions? No questions? Okay. If there's no questions, I'll end the recording and we can wrap up class for the day.